In this video, we will be talking about the half subtractor circuit. Before you go through this video, make sure that you go through the basics of subtraction of binary numbers. Let's move on to this video. Half subtractor. Here I am going to have 4 folds in this video. Number 1, what are we going to do in this video? And number 2, what is half subtractor? What is its purpose? And number 3, how are we going to design the half subtractor? And finally, implementation of designed half subtractor using logic gate simulator. Our aim is to design and implement half subtractor using logic gate simulator. Here we are going to have 2 tasks. One, implementing the half subtractor using 1 XOR, 1 NOT and 1 AND gates. And second one is, how are we going to do the same half adder with the help of full adder? The clue is by taking the 2's complement. You take the 1's complement and add 1 to the least significant bit. So, you are basically converting the whole subtraction process into the addition process. So, task 2 is using full adder. Let's see the theory. So, half subtractor circuit is a combinational circuit where you don't have any memory and the output at any instant of time depends on all combinations of your input. Basically, it is used for subtracting 2 single binary numbers. If you take the half subtractor module, you will be having 2 binary inputs and 2 binary outputs. So, difference and borrow. So, you have 2 inputs, 2 output system, right? So, if you want to name the 2 inputs, we'll just take it as A and B are my input variables and D, the difference, and small b is my borrow. So, now let's move on to the design. Step 1, identify the input and the output variables that we have already assigned. A and B are my input variables. It can either be 0 or 1. The output variables are the difference and borrow. Next, step 2, draw the truth table. So, A and B are my inputs, D and small b are my output. So, if I have my input 0, 0, my difference is 0, I don't have any borrow. If I have 0, 1, my difference is 1 and my borrow is 1. If I have 1, 0, my difference is 1 but my borrow is 0. So basically it is A minus B, right? If you have 0 minus 1, you have the borrow 1 and difference 1. And if you have 1 minus 0, you have the difference 1 but the borrow is 0. If I have both 1, A minus B, the result is difference is 0 and borrow is also 0, right? And move to the step 3. With the help of the truth table, we are going to draw the Karnaugh map for the difference and the borrow. Let's see for difference. I'll be having this map. I'll be looking at the difference column. Right? Accordingly, I'll just fill up. 0, 0, I have 0. 0, 1, I have 1. And 1, 0, I have 1. And 1, 1, I have 0. This is for difference. Then for borrow, I will be looking at the borrow column. So for 0, 0, I have 0. 0, 1, I have the borrow 1. 1, 0, I don't have borrow. And 1, 1, I don't have borrow. Right? So now that we have drawn the Karnaugh match, and step 4 is obtaining the Boolean expression, right? Here also we are going to have two forms. One is obtaining the Boolean expression using sum of product form. So I have encircled. So my output would be D is equal to sum of product form. What is this? A bar B plus A bar B plus A B bar, right, which I can simplify this as A XOR with B. Then the borrow is, I have only one, right? So A bar B. So now that I have got the Boolean expression for difference and borrow, right? With the help of this Boolean expression, I am going to draw the logic diagram, right? It is very simple, right? It looks similar to the half adder if I remove this inverter. Yes sir. The output of the summer, that is a half adder, for the sum is the same as the difference, right? Here also we are getting D is equal to A XOR B. There also you get the same, right? Sum is equal to A XOR B in the case of half adder. And what is the result of carry in half adder? It is AB, and here we have borrow is equal to A bar B, right? The only change that you need to do here is you need to invert the A input and pass it to the AND gate. So this is the implementation of half subtractor, right? AB is my input, DB are my outputs. So let's see how to implement this in the logic gate simulator. So I open the logic gate simulator where I'll take the component. So what component that I require here? I need XOR gate, right? Okay, then what else I require? I need the inverter, right, for inverting the input A. Then I will be requiring the AND, right? I will be requiring the AND gate. Then I will just take the input. So how many input that I require? 2, right? So I will just take Control C, Control V. Okay. These are my input. I name this as A and B, right? So output, I am going to have two output. One is for difference, another is for borrow, small b. Okay. So now that I have got the input and the output and all the elements that I require, so wire it. So what is difference? What is the difference? It is the same, right? A XOR B. Okay. So what I'll do, I will just do connecting. Let me take this here and I'll just take this here. Okay. So AB, that is A XOR B, that is your difference. Borrow is, I need to just invert the A and pass it to one of the inputs of the AND gate. Then another input is from B, right? What is this? Borrow. So here, for the confusion, I will just name this as let me name this as T. Is a borrow, right? So what is the output here? A bar B. Okay, A bar B. If you go and look into this circuit, I will be having 2 input, 2 output, right? So A and B are passed to the XOR gate where I will get the difference, and then I will invert the A and pass it to one of the inputs to the AND gate, and another input would be B where I will get the borrow. The expression is A bar B. Okay, let's verify. If I have both the inputs 0, I get 0 0. If I make 0 1, I get the difference 1, and also borrow 1. And if I make 1 0, I have the difference, but I don't have the borrow. If I have both the inputs on, then my difference would be 0. I don't have any borrow, right? So this is how you verify your truth table of the half subtractor with the logic gate simulator. Same way, if you want to have the display in the oscilloscope, I can very well have it in the oscilloscope. You can see over here. I am just going to change my input as 0 1. You could see A is 0, B is 1, and your difference is 1, and also your borrow is also 1. If I make 1 0, if you see here 1 0 1 0, you have the difference 1. You could see difference 1 and borrow 0. If I make it both 1, if I make it both 1, what will happen to the outputs? Difference and borrow, I have both 0, right? So now that the truth table is verified with the implementation in the logic gate simulator. Okay, so we have done with the implementation of half subtractor in the logic gate simulator, and if you closely observe the half subtractor, you could see the limitations, right? Can you guess what is the limitation of half subtractor? It is very similar to the half adder what we have already discussed. We don't consider the borrowing from the previous bit. That is the major drawback in the half subtractor. It doesn't take into account borrowing from the previous bit. As usual in the real time scenario, we need much involvement with subtracting multiple number of bits. That cannot be accomplished using half subtractor. Logic is very simple. If we are not able to achieve it with the half subtractor, obviously we have to go with the full subtractor. Practice exercise. Now it is your task to design and implement the half subtractor using full adder and verify your results with logic gate simulator. And as I have given the hint in the introduction, you are going to have the 2's complement so that you convert the subtraction into addition. So how do you take the 2's complement? First step, you have to use the first 1's complement using inverter. Then just you need to add 1 to the least significant bit through your input carry. So finally your circuit would be having a adder with inverters placed between each data input and corresponding input of the full adder. So hints are given and it's time for you to practice the half adder circuit using full adder. I believe this video would be useful to you. Let's see in the next video. Thank you.